What's up, everybody? What's up? What's up? Welcome back. Dr. Jaws here, and tonight we are going back to the tropics. I feel like we've been doing quite a few deep water species lately, which is very appropriate for the Halloween season. But now we are finally out of spooky season into November, and we're going back to shallow water with the white-spotted bamboo shark, Chiloscyllium plagiosum. So I'm very excited to talk about this species as like. Oh, hey Howard, what's up? Good evening to you as well. I was just about to say I was very excited about talking about the species from a unexpected perspective. It's a tropical shark. Very popular in aquariums, very beautiful color pattern, and really cool marine environment that it's used to. But interestingly enough, it's also a key species for genetic studies. So there's a lot of genetic research out there on this species in particular that we have access to, and I'm really excited to kind of go through that tonight. We've never really done a genetics episode before, so I think covering the white-spotted bamboo shark kind of from that perspective would be really cool. So without further ado, I think we'll start out with just the ecology of the species and just some unique features about it. And then we'll dive into the genetic studies. But I hope you had a good weekend, Howard. Hope you had a fun Halloween. I stayed in, but watched Hills Have Eyes, which is really if anyone likes scary movies, it's a very good scary movie. But it is a horribly disturbing. It's rough. It's rough. So. Had my share of spooks for the year, and now I'm happy to be back in just normal, chill fall vibes. Although, if you are in the United States, it is election season. Tomorrow is election day, and that is also a whole other share of spooks. Regardless of what side you're on, it's been a very anxious time for the Americans, like for the past, I don't know, month to 3 months. So it's finally going to be over tomorrow. Tomorrow's election day 2024. So very interesting times. So, but here we are with the white-spotted bamboo shark, which is nowhere near the United States. This is an Indo-Pacific species. I think, let me see the range map. IUCN Red List has this. Okay, so Indo-Pacific in the northern Indian Ocean, Indonesia, southern China, and Southeast Asia, as well as Japan. So, and what's kind of cool is that this is a shallow water tropical species that is near threatened. So it's compared to other sharks, it's actually doing pretty okay. Because a lot of tropical marine species and tropical shark species are vulnerable or endangered. So it's really cool to see that at least this one is actually comparatively doing well. And actually, while we're here, let's take a look at why the species is doing well. I'll put a pause in this video really quick. This is an interesting documentary called Wildlife Instincts White-Spotted Bambooshark on a channel called Free Documentary Nature. But we won't cover the whole thing tonight just to save on time, but there is some really cool footage of this shark in particular. So we'll take a look at that and just focus on the clips with the white-spotted bamboo shark. So, the white-spotted bamboo shark is a small nocturnal shark with a broad distribution in the Indo-West Pacific, ranging from southern India to southern Japan, including the Indo-Malay Archipelago and Papua New Guinea. It inhabits shallow coastal and shore and coral reef habitats to a depth of 50 meters. So that's actually very, very shallow as far as sharks are concerned. So there's no refuge at depth, as far as some shark species have such a wide range that they can escape fishing pressure in deeper water. But this species is a pure, shallow tropical coral reef dwelling species, so that's a very limited depth range. The species is a bycatch of a range of artisanal and industrial gears, including demersal trawl, longline, and gillnet. It is subject to intense and largely unmanaged fisheries across its range and is landed and utilized for food, although it is of low value, often in high numbers. Fishing pressure is intense across a range of species, yet it is still commonly landed in parts of its range. It is the most abundantly caught shark in parts of Taiwan, Malaysia, and Indonesia. There is no long-term trend data on the populations. General long-term shark population trends have shown declines of 37 to 99%. That's a way too large of a range. That's almost that's really very, it's too broad of a range to kind of have an idea of what's going on with this. The relative proportion of bamboo sharks in shark landings has increased significantly over recent decades in the region, which may be in response to the overfishing of large sharks resulting from mesopredator release of the species. Interesting. So, like a couple other sharks we've talked about on this channel, this shark may have natural predators in the form of larger sharks that occupy coral reef habitats, like tiger sharks. And if larger sharks are being fished out, it allows smaller sharks to flourish and replace their niche. So that's what mesopredator release is, where the larger predators allow the mid-level predators to kind of take over. So, for a modern Batman analogy, Carmine Falcone being out of the way allows the Penguin to rise. If anybody is watching the new Penguin series, so. It is a relatively productive species and has not declined to the extent that other species have in the region. It is suspected the white-spotted bambooshark has undergone a population reduction of 20-29% over the last 3 generation lengths based on actual levels of exploitation, and since is near threatened, nearly medium vulnerable. Okay, so that's a little worse than I thought, but compared to other shark species, not horrible. So little bit. This might be a species that will become vulnerable in the future, but we don't seem to fully. The fact that in this intensely fished area that there's still high catches of this species indicates it might be able to withstand some of that fishing pressure. This is also a egg-laying species, and I think the litters are prolific. So we'll take a look at that as we learn more about it. There's a really cool video on the development of eggs for the white-spotted bambooshark. So let's take a look at that. And I've never seen a shark egg video or shark development video that an egg video that shows the development of a shark pup. So clearly. So this is a white-spotted bambooshark egg case that is backlit. So usually the cases are a very dark amber color, but when exposed to very strong light, like in an aquarium setting, you can kind of really see the development. So here in the center is the yolk, and then on the top, this little white area here is the actual shark, and so we get to see how the shark grows. So this is actually really incredible to watch, where this stage, and actually we can go stage by stage. So this stage, this is a really small embryo, where you can kind of see the notochord, where it's like the template for the backbone that makes all vertebrates and or all chordates. The thing that unites them is the fact that they have that notochord running along the back of the body, like that central column of nerves going from the brain to the tail. So all vertebrates have this, and the simplest animals that are chordates are this group of fish-like things called lancelets. They are really they almost look like little leaves, but they have like a very simple notochord. I don't think they have a backbone, but just a simple notochord, and it kind of bends and turns as the animal moves through the water. So it's kind of cool to see at this stage of development that this embryo almost resembles a little bit of a lancelet, and especially like the thinness. Here, this looks a little bit more shark-like, where you can get to see some sinusoidal movement, so like more like snake-like movement. This stage, you can see the feathery gills, so like the red gills clearly on the sides of the head. Shark's definitely getting bigger and much more vigorous in movement. Here is a very late stage embryo, where you can see the eyes, so like the dark spots of the eyes. Here is still a while to go, but you can see some coloration on the back. And what's kind of cool is that you can see some buccal pumping already, where the shark is you see little fins. The shark is actively pumping water through its gills in its egg case. Here the egg is about ready to hatch. Very deep coloration, and it's cool to see that when the shark hatches, it's going to be a fully formed predator. It will be ready to hunt the minute it emerges from its egg. And here we go, a cute baby white-spotted bamboo shark with nice rounded little fins wiggling along, and like it's a very, very small individual being given a piece of food that it's ready to gobble up. So you can even see the nasal barbels, which are sensory organs to help the species find prey on the seafloor. And he's being hand-fed in this aquarium. He's very happy. And look at him standing on his fins, by the way. A lot of the carpet sharks do this. Epaulet sharks famously do this, but he's actually using his pectoral fins as kind of like a perch, which is really, really cool feature. It shows how articulate the fins can be. So really great video on development. So this is by a YouTuber called Zone Shark. So it's actually really cool to see. As far as just that's a very, very intimate viewing of shark development. So one thing that's cool about sharks and rays, so we saw the buccal pumping for the shark. When rays develop, or skates, or I guess skates develop. Oh no, it is rays. Sorry, one of them I think it's skates. I'm sorry, it's skates. Skates lay eggs. Rays give live birth. But for skates, when they lay their eggs, the juvenile skates have to actively wag their tails to pump to kind of help circulate water in the egg case. So they keep doing that in order to like the skates keep waving their tails or wagging their tails to help circulation in the egg. And then it's kind of cool to see in the early stages of development for the shark, lots of movement here. And you can see a little bit of that tail pounding a little bit, but I think this is a little bit different where the shark relies mostly on buccal pumping, so sucking water through its mouth and through its gills actively to kind of do the same effect, which is recycling water through the egg case and recycling oxygen in that sense. So pretty cool to see. But this documentary has some really cool clips on adult white-spotted bamboo sharks, so we'll just kind of fast forward to those. So they get to be pretty fair size. It's cool to see, again, this is a species that likes to hug the seafloor, be very close to it as it searches for prey or a new spot to hide. Beautiful color pattern. That can blend in really well with its surroundings. The intermittent dark and light bars kind of mimic the rippling waves of the water. And also with the spots, it mimics debris on the seafloor, like seashells or just, like algae. So it's if the shark wasn't moving and just laying on the seabed, it would be, for a passing predator, kind of easy to miss. Especially here, you can see these individuals wriggling into these crevices. Let me expand this for a better view. This is a really beautiful fish, by the way. I don't know what these are. I'm not as familiar with Pacific wildlife, so really, really pretty. I've never seen those fish before. And I don't even know what group they are, and they almost look like angelfish or butterfly fish, but I don't think that's them. But yeah, here is our white-spotted bamboo shark cruising along the seafloor. I really like kind of the slope of their head. The eyes are on the top of the head, which is kind of interesting. Not really at the midpoint of the body, they're like right at the top of the head, but it has this beautiful slope down. Nice broad pectoral fins and pelvic fins. The dorsal fins are very far back on the body. It's cool to see that the barbels are kind of almost like pointing outward as this individual is moving along the seafloor. Again, these barbels are used for sensory, or thought to be used for sensing vibrations, or kind of amplifying sense of vibrations in the water, so as the shark detects prey items. It's really cool to see a camera wedging into a crevice and the shark again, doing buccal pumping, so he's just sitting there actively pumping water over his gills, living very comfortably. I always love animals. I don't know about you guys, but like I always love the idea of animals like in burrows or in like these little rock crevices where it's like, no matter what is going on in the world, no matter what happens, they're just chilling here, and the world turns, and they're just kind of tucked into their little spot, looking for food, taking a nap. This is really cool to see. This individual is moving backwards. Which I think that's particularly fun. I'll rewind to have another view of that. I think it's actually particularly interesting because I don't know if anyone has seen the movie Deep Blue Sea, but there's a scene about those... Deep Blue Sea is kind of like Jaws, except it's about like these bizarre mako shark hybrids. And there's a scene where the mako sharks swim backwards, and the scientists are like, oh my gosh, they're learning, they're doing something that sharks can't do. And it's kind of a dumb scene in retrospect, but it's kind of funny because it reminds me of how there's so many different sharks that could do so many different things, and this particular shark can very comfortably move backwards. So and it's really cool to see how he's like repositioning himself. Again, I don't think it's very popular knowledge that sharks can be very articulate in their movements, especially with the movements of pectoral fins. I wonder if this is probably is part of the group of walking sharks, because epaulette sharks are pretty closely related. They are a different kind of carpet shark, or Electolobiform. So these white-spotted bamboo sharks are part of the same order, or Electolobiforms. So I would not be surprised if this species too walks on the seafloor. Look at this! That was really cool. So this individual just yawned and stretched out his jaws. And other sharks do this. Famously, sand tigers do this. Look at this. He's protruding his jaws right there. Look at that. So the upper jaw, and it's kind of funny, like the upper jaw is so small in comparison, compared to like this big boofy head. But it is protruding, kind of like goblin sharks or sand tiger sharks. It was a really, really cool sight. We'll see it one more time and kind of keep rolling with the video. And nice shot of the barbels too. And also like the curved nostrils, so it probably amplifies scents coming through the water. One more time. That is really cool to see. That is super, super cool to see. So just stretching his jaws out just like a sand tiger shark or a... he's doing it again. Sand tiger shark, or these are so cute. Sand tiger shark or goblin shark, except it's a much cuter, much less fearsome package. Look at this. The eyes and the spiracles are very close together too. Spiracles are, in fish evolution, they're very extremely modified gill, or former gill slit. So it's a feature that's similar to the true gill slits of the sharks, but it's used a little bit differently for water movement, kind of pumping water through the shark's head. Beautiful, beautiful eyes, by the way. Kind of like these cool diagonal slits. Nice shot of like these nice ridges along the body. Beautiful close-up on the color pattern. You can kind of see a little bit how this species and whale sharks are, part of the same order. Just like the spots and like the ridges on the back. They kind of have the same dramatic look as whale sharks a little bit, which is really cool. This is a male, so you can see the claspers right here. And close-up of the large claspers. So this is probably a mature male. This one is a female. There are some good clips about mating. And this is actually really good. I wonder if this documentary might include that, but this might be a good species to kind of study the mechanism of shark mating, which, it's kind of... I think it's been seen with... no ads. I don't want ads. I think it's been seen with nurse sharks, lemon sharks, and sand tiger sharks, but it's not a very commonly documented event. So, oh hey, Minjus, what's up? Welcome back. Sorry, I just saw the comments. Yes, it is a myth that sharks can't move backwards. So, and I feel like that was perpetuated by Deep Blue Sea. I don't know if you've heard of this movie, but I remember when I was a little kid, it was like this fresh new like thing. It was Samuel L. Jackson was in it, and I think he might have been, if I recall correctly, maybe the only big name in it actually. But it was this fresh new thing, and that was a big scene, and it might have perpetuated the whole myth of sharks can't move backwards when in reality they can. It kind of sounds a little bit like the myth of sharks have to keep swimming in order to survive, and we've seen already so many sharks that have completely dispelled that myth, where they could just chill on the seafloor. Oh, yeah. Good question. How and why are the eyes in the spiracle so close? Also, love this comment. I definitely agree. Nature is gorgeous as far as like the wee little shark young. I completely agree with that. I don't really know why the eye and the spherical would be so close and what the advantage would be. But that's a really great question. So hopefully, in some of the studies tonight, we'll be able to kind of learn more about that. So here are some captive bamboo sharks all huddling together in this little bit of PVC pipe. That's a beautiful, it almost looks like, oh, it's a cow-nose ray, isn't it? Wow. I love cow-nose rays. They have unfortunately left the bay now. They have moved south for the winter at this point. A lot of the sharks in my part of the world have left. We now have dogfish coming back since the waters are getting colder. So it's cool to see the changing of the guard, if you will, the changing seasons. We have two different regimes of sharks. We have the summer sharks that leave around October, and then the winter sharks come in around November. This is around the time of year they start coming back. So these guys are really cute. I love seeing that this group of bamboo sharks, they're actually a little bit darker in coloration than the wild ones we saw from the documentary clip. So these are being hand-fed. Oh, and it makes sense. I just saw that was from Florida. It totally makes sense they have cow-nose rays in this tank, because cow-nose rays are very populous along the east coast of the United States. Currently, they're my favorite ray species. They have this very cute look about them, and it's one of the few rays I've seen in the wild and have been able to snorkel with in the wild. So I really, really love these rays a lot. So. These are very cute shark. I kind of love. I don't think they're nuzzling. I think he's probably just trying to steal food from his buddy. But very, very cute though. Here is. Whoops. First. Nope. What happened? I had a clip of. There we go. First white-spotted bamboo sharks born at the zoo, Houston Zoo. So again, these are egg-laying sharks. This is interesting. Look at the color pattern. That is actually eerily similar to the very striking black and white pattern of zebra sharks. And they do live in a similar range, and you have to wonder if this black and white pattern is similar to the zebra shark pattern, where it's thought to have evolved to mimic poisonous sea snakes. So sea crates, I forget what kind of sea crate it is, but there is a famous sea crate that is a black and white pattern. And the theory is that the baby sharks have evolved this black and white pattern so that they can look like the venomous snakes, so that predators don't go after them. Because they mistakenly think that this is a snake, and predators don't want to get bit by what actually turns out to be an adorable, harmless baby shark that needs all the advantages it can get in the wild. And so it's really cool to see that this is, although this is in the same order as zebra sharks, they're two different groups, and yet they still evolved the same kind of color pattern. It's actually really, really cool to see. We have one more clip, and this is a wild individual. I'm just liking and subscribing. This is Tropical Research and Conservation Center. But this is a really cool adult individual. You could tell it's an adult just because it's not only it's a bit large, or quite a bit larger, but also the color pattern is a bit less stark. So it's more, and I feel like a lot of older sharks, like when sharks are born, like for a lot of shark species, the younger individuals They not only look more cute and rounded in their features, but their colors also tend to be a lot sharper, brighter, starker. And then as they age, they get to be a little bit more beige, a little bit more brown, a little bit more muted, a little bit more lived in. I feel like a lot of juvenile animals have this kind of transition, which is really cool to see. One of my favorites are American alligators, where baby alligators are this beautiful black and yellow pattern, and then as those animals age, they become more of like a uniform gray. For sharks, tiger sharks are a good example. The juveniles are these beautiful, like spotty, stripy animals, and then they fade into the big bars of the tiger shark. Zebra shark is a big one, and then these bamboo sharks as well. So. All right, let's learn more about this species. So we'll kind of take a look at some of the generic, or not generic, but like general notes on the white-spotted bamboo-shark, and then we'll dive into genetics. We've never really done a genetics episode. It's a field that I have like passing familiarity with as far as sharks go. My favorite thing about shark genetics is species hiding in plain sight, so or genetic complexes. So sharks that are considered to be one species, when you take a DNA sample of individuals from around the world, you realize, oh my gosh, they don't breed with each other to such a degree that they actually might be different species. So those are called gene complexes, which are super cool. So I don't think we'll get that for this species tonight, but there's so many genetic studies on the white-spotted bamboo shark. I'm curious to take a look. So, yeah. I'm just catching up on comments too. What's an example of mimicry? Yes, that's a really good. That's a really good shark trivia question. And yes, thank you, Minjas. It's sad to see species go for the winter, but that's a good reminder to appreciate the species that only show up in the winter. Thank you. I feel the exact same way. It's funny. This didn't used to happen to me when I was younger, but as I get older and as I do more like snorkeling and adventuring, I kind of get a little emotional as we transition from summer to fall to winter. And I love the fall and winter. I love the holiday season, but it feels sad to see like the animals, like a lot of those warm water animals disappear, and the leaves fall and everything. But you're absolutely right. It's like transition where the cold water species are coming down here. So it's a cool opportunity to see New England species coming down to the Mid-Atlantic. So we get the hake, we get the dogfish, we get the lion's mane jellyfish, which is like I think the only like northeastern jellyfish that could theoretically kill you. It's a very venomous species. Down in the bay, in the Chesapeake Bay, Virginia area, they don't get to be that big. But up in New England and in Canada, they get to be like 5-6 feet in diameter. They're humongous, and those are lethal jellyfish. So very cool, very very cool species. So, but here we go. White-spotted bamboo shark, Chiloscyllium plagiosum. What to look for? Small shark with spots. Dorsal fins are straight or convex in your rear margins. Anal fin is set very far back. Oh, you're right. Okay. I forgot about this. So these sharks are so interesting. This group of sharks is so interesting because here's the anal fin, but it almost looks like the lower lobe of the caudal fin. So, and really the anal fin and the caudal fin all work together as this like one tail unit. So it's kind of trippy to see. So you have the pectoral fins, pelvic fins, first dorsal fin, second dorsal fin, and at first glance this almost looks like a squaliform shark, where it's like, oh wait, where's the anal fin? I just see the tail, but it actually works like kind of more like a consistent paddle. So that's actually really cool to see. I remember there was one shark that we did on the stream that was very similarly shaped, and it was like, oh, that's really surprising, and it threw me for a loop for a second. I was like, wait a minute, this isn't Orlectolobiform. It's a carpet shark. I know it has to have this. So, let's see. First dorsal fin origin is opposite, just behind the pelvic fin, which is also really far back. A lot of the classic sharks that we know of have their dorsal fin right here, on the midpoint of the body, but the dorsal fin for bamboo sharks is really far back behind the pelvic fins. Pretty interesting. And this is a cool feature. It has lateral ridges on the body. So we saw a really good view of that in that first video, skipping the ads because I don't want any, whatever protection they were trying to sell me, I don't want it. Here we go. You can kind of see it here, but there's a shot that, oh, there we go. Yeah, you can really see it here, like those beautiful defined ridges that, again, are analogous to whale sharks. They really do remind me of whale sharks, having those gorgeous ridges along the body. And what's especially cool about these ridges is that they're not lateral lines. They're just kind of more like just this really cool muscular looking feature. And then as a refresher, lateral lines are, every fish has them, but they're a line of pressure sensing organs along the body. So there's all sharks and all fish have a lateral line that is in the middle, at the midpoint of the body. It's usually very faint, but you can clearly see it with the naked eye. And these are, it's a feature that allows fish and sharks to sense pressure in the water. That's why if you're like looking at fish, and if you like are like, say you're at the edge of a pond and you're trying to catch a fish with your bare hands. Sometimes people do that. I do that sometimes, like just for fun. I put them back, but and you put your hand in the water and the fish instantly reacts. It's not so much that they see you. I mean, they probably do see you, but it's also that they feel you. So the minute you put your hand in the water, you're displacing the water, and that displacement is pushing against the fish's body. And it's really cool, actually, because like we don't really have something like that. I mean, an equivalent would be like feeling like a draft, you know, for humans. So it's pretty cool as an evolutionary feature. Let's see. This is very strange. This shark has a Pokemachine's dark body with numerous light and dark spots. This must be a typo. That's really funny. And Shark Research Institute is a very well-respected thing. That's very strange. Okay. I don't know what that means. So, the shark has a dark body with numerous lights and dark spots, dark bands, and saddles not conspicuously edged with black. My guess is whoever wrote this was looking up whatever this is and inserted it on accident. So, the shark prefers inshore waters, which it is usually seen on the bottom or on the reefs in the tropics. Bony fishes and crustaceans are its prey, and it is oviparous, meaning it is an egg-laying shark. The shark is nocturnal. It rests in reef crevices by day and feeds at night. So, and again, we did see the conservation status earlier. It is currently a nearly threatened species, but on the verge of being vulnerable. So. Oh my gosh, I just love this comment. It gives me a weird form of jealousy. Why don't I get to feel the water? Oh my gosh. Of course, the New England jellyfish is highly toxic. Oh my gosh. Yeah, it's funny that one. I feel like on the East Coast, it's of the United States. It's the lion's mane in the north, and then in the south, in Florida, when I used to live in Florida, Portuguese man-o'-wars, which are not a jellyfish. They are a weird group. I forget what they're called technically. They're what are those? They're a very strange-looking colonial organism where I guess an equivalent would be like bryozoans or a sponge, I guess, except it's not that at all. It's something completely different, but it's not a true jellyfish. But those things are lethal. So I fortunately have never been in the water with one, but I have seen them washed up. So they're beautiful. Man-o'-wars are beautiful. Like they're just this brilliant electric blue and purple. They're gorgeous animals, but they're actually, while we're talking about them, let me just look these up really quick. Lion's mane jellyfish. Just to kind of illustrate what these animals look like. So this is the one in New England, the lion's mane jellyfish. This is how big they get. Although that almost looks like a slightly different. That might be it. That might be a slightly different species. This, I don't think that's real. That seems doctored. This seems a little bit more real with the scuba diver right here. This one on the top left, this is kind of the size of lion's manes that I see in the bay. Yeah, that's a pretty big one right there too. So this is what they look like washed up. They're very splotchy and deep red. So in the water, they're very beautiful, but when they wash up, they are not the most attractive looking jellyfish. And then for comparison, Portuguese man-o'-war, which is not a jellyfish, it's a different kind of animal. But here it is. And you can actually tell it's not a jellyfish too, because you see that it doesn't have a bell. It doesn't have like a circular pulsating bell. It has really like a float with dangling tentacles or dangling appendages. But these are completely lethal. Very pretty all around, like gorgeous, gorgeous animals, but super, super dangerous. So, yep. Fun little tangent there. I don't know if I missed anything here. Okay, yep. So we'll move on to St. Louis Zoo bamboo sharks. So this is a very popular aquarium species. So already just now we saw, I think it was like the Texas aquarium. There was like a Japanese aquarium, and then now we have St. Louis Zoo. I can't recall if I've ever seen these personally. I probably have, honestly. Just because these are very easy to keep, and it's a great shark to show embryonic development as far as the eggs go. I don't know if you were able to see this ninja, so I'll just play it just in case. Let's make this full screen. But here is the embryonic development of a white-spotted bamboo shark. So it's a great... this shark and I think cat sharks, like the chain cat shark, are great species to study. Ovipary, so egg-laying sharks, and how that works, and how their development works. So you can see the shark in this egg case, attached to its embryo and slowly growing, and slowly developing features like gill slits, fins, coloration, eyes. It's really cool to see the different stages as the shark grows. So, and I pointed out earlier that you can also tell that the shark is actively pumping water over its gills, even in its egg case, as a way to circulate oxygen, like dissolved oxygen in the water, for its gills, so that it can receive oxygen. But yeah, and it's really cool to see that when it's close to hatching, you can almost get that full coloration and really see that beautiful color pattern. And then here we go, the wiggly, wiggly young white-spotted bamboo shark. Very cute, fully formed predator on a very small, adorable scale. So there he goes, munching on the hand-fed item. So let's see. These are sometimes known as long-tail carpet sharks and cat sharks, but these are not cat sharks. These should not be called cat sharks. They're a completely different group, and I feel like that's really confusing actually, because it's like cat sharks are such a huge group of like over 100 shark species that we shouldn't add carpet sharks like bamboo sharks to that collection. They're just evolutionarily they're just on a completely different branch. So we really shouldn't be calling them that. So. Little is known about their social life, but they are commonly observed congregating in shallow reefs. And then this is kind of something I would say all sharks have. Female bamboo sharks have thicker skin than male bamboo sharks, but that's kind of something that all sharks share. Females, as far as sharks go, tend to be larger and have the thicker skin, just because male sharks usually tend to bite to female sharks for mating. So female sharks have developed thicker skin. So. Yep. Born to murderize, love it. Oh my gosh. And I could see this. Here we go. Bamboo sharks are also known as cat sharks because the nasal barbels near their mouths look like cat whiskers. Like, I get that, but I don't really think I still think that's not a good name for them. The barbels are actually sensory organs that help them locate food hidden in the sand. The sharks use their muscular paired fins like legs to help them crawl along the ocean floor or reef, so that's a lot like epaulet sharks. Brown-banded bamboo sharks often hunt in tide pools. They can survive up to 12 hours out of the water. That is really cool. I wonder if this documentary. I'm just gonna fast forward. So it does have a shark mating clip, but I want to see if there's a clip on the shark hunting in tide pools and like getting out of the water to do that. Probably not. I'm not seeing anything yet. But that's a really cool feature, and just kind of like a really fantastic piece of evolution. I think one of the Blue Planet, or one of the it's not Blue Planet, but it's like Planet Earth or Life. It's one of the David Attenborough documentaries. I think they did have a epileptic shark sequence. So you can see epileptic sharks going from tide to tide. Super cool. Here is a white-spotted bambooshark hunting at night near the surface too. Pretty cool to see. This is the male. Another male. With the large claspers, is probably an adult male. I feel like I can be corrected on this, but I'm pretty sure if the claspers are beyond, if they're larger than the pelvic fins, then that means the male is mature and ready to mate. So. Or mature enough for mating. Let's see, I think there was a clip. This might be it. So this is a good example of, and a lot of sharks do this, but this is a male shark biting a female shark's fin. Usually it's a pectoral fin, but this individual is biting the pelvic fin. And usually for shark mating, that happens. Shark will bite, a male shark will bite a female shark, so he can attach to make sure that he's able to fertilize internally. Although this individual is biting in the wrong area, so. But this is why the female sharks have thicker skin, because you can imagine like all sharks have these like razor blade like teeth, like no matter what kind of shark you are, whether you're a shark that eats fish, or a shark that eats like shellfish, like mollusks or snails or anything. Oh, here we go. Now he's attaching to the pectoral fin. It's like all sharks have those really razor sharp keratin teeth, and so like the female sharks need to have the thicker skin to endure that. This is actually a really incredible clip where you can see the claspers. I don't think it's called splaying, but you can see how they're actually moving forward. So they're kind of opening up and outward in order to do fertilization, and then you can see the clasper entering the cloaca. So the shark is actually mating with, or the male shark is mating with the female shark. It's internal fertilization, so analogous to mammals. And which is kind of cool to think about because, sharks are so distant from mammals on the evolutionary tree, because in between them you have frogs who lay eggs and have external fertilization. Like lots of bony fish, they also do the same thing where they lay eggs and have external fertilization. But then sharks, great, perfect time for an ad. Sharks, like mammals, have and birds have internal fertilization, and so these are two lineages that are separated by millions of years of evolution, but they have this similar kind of like reproductive strategy. And what's even wilder is that this group of sharks lays eggs, but there's other sharks that give live birth and actually have a placenta, very similar to mammals. So it's really incredible that millions of years of evolution go by, and yet just you can have analogous features across so many such a wide range of groups of animals. So it's pretty amazing to see. So this is another one, Akron Zoo. Let's see what we have, if there's anything new. This is a nice summary actually. Bamboo sharks, as well as nurse sharks and whale sharks, belong to a family of sharks commonly called carpet sharks. These animals receive this name through their carpet-like markings. This is about sharks in general, so we'll kind of skip that. White-spotted bamboo sharks have a unique method of consumption. The shark has small teeth that can be used to grasp or crush prey, but new research shows that the teeth will also fold backward within the mouth. Ooh, we haven't heard that before. This allows the shark to protect the tooth, as well as to use the flat surface of the tooth to crush crabs and other crustaceans. That is really cool. If I'm understanding it correctly, if I'm using my hand as an analogy, the shark can like lunge forward with its upper jaw, but then protect it so that this part of the upper jaw can be flat. So it's like, if you can imagine, actually, I guess if you can imagine, it can grasp prey with the upper jaw, to clutch it and then, swallow it. But then the upper teeth fold inward, and so it can also pummel prey, like just clamp down to crush shellfish. So if you have a fish, the shark can snap up with the sharp teeth to grab the fish, and then if you have like a mussel or like a crab, the shark can fold the teeth inward to crush it. That's really cool. I've never heard of that before in sharks, so that's actually extremely cool. So, whoa! Oh, Mingus. This may be common knowledge that I recently learned, but in my etymology course, I learned that there are even insects that give live birth in a way similar to how it's done in sharks. Wow, that's actually really incredible. So, really, really interesting. I'm curious what group of insects that might be, because I'm so used to insects laying eggs as well. So that's actually really cool. Here's our good friend Andy Merck, sharkstorays.com, and I'm really excited for this because he will have dive notes on this species. So white-spotted bamboo shark, white-spotted carpet shark, and we can learn what it's like diving with them. So here we go. This is an easy to approach shark with slow, casual movements. It will bolt. This might seem really awkward. This is a very common term. This is a very common term with fishes or fish biology. I guess wildlife biology in general. So will bolt if molested, meaning if a fish or a shark or whatever is like touched, the shark will like swim away. It seems very strange, I think, from a human context to see that terminology, but it's just want to point out that's very common terminology for wildlife observation. It comes up a lot with sharks in particular. So, or I guess fish, like underwater animals in particular, because you don't have a lot of senses underwater, and a lot of underwater animals are very easy to approach because you're not used to humans. So you have more opportunities to touch them versus if you were observing like a moose or like a bird, on land. You have more opportunities to touch the wildlife underwater. But unfortunately, people don't really respect that. And I think one of the biggest concerns is there's a lot of coral reef fish that have protective mucus on their skin, where if you touch them, you're kind of taking it off them and exposing them to disease and exposing them to friction with the coral that can actually cut into them. So it's better not to touch anything, to look but not touch in the underwater world. So that's what that's referring to. So that kind of reminds me, I think butterflies and moths are similar because they have very fine scales, and if you touch the scales on a butterfly or a moth, you actually remove them, which really impacts their flight. So diving logistics. Although white-spotted bamboo sharks occur throughout most of Southeast Asia, they're infrequently seen by divers. Interesting. This may be because they're relatively scarce or because they tend to be quite secretive, resting by day in deep crevices. Kaneura in Kochi Prefecture, Japan, is the exception. In Kaneura Bay, a mating aggregation of white-spotted bamboo sharks can be seen in May and June. During the day, it is not uncommon to find 20 or more bamboo sharks hiding in rock crevices. At night, the males swim around the reef looking for females to mate with. So a lot of that footage that we just saw, probably, it might be from this area, or likely, if it's not from this area, probably is a similar kind of thing. It probably was filmed in May and June as far as that mating timeline. So that's really cool. Malapattaya Pascua Island in the Philippines has a reasonably abundant population of white-spotted bamboo sharks. Patiently moving along the reef, searching under plate corals in the 10 to 20 meter depth range is the best way to find one. That's really cool. Behavior is nocturnal. These sharks rest by day in crevices on the reef or under corals. Okay. Oh, this is what I wanted to find out. So these sharks lay about 26 eggs each year. So 26 egg cases are laid each year. In captivity, females deposit 2 egg capsules at a time, on average every 6 to 7 days from spring to summer, or about every 6 days from winter to spring. The eggs hatch between 110 and 135 days after being deposited on the reef. So that's actually, for sharks, that's really good. What is that? That's a third of a year, so that's about 4 months. That's actually extremely good for sharks. That's really, really fast. So it kind of makes sense that these are pretty abundant, and they're not as devastated as other shark species in tropical environments. Pretty cool. So here's some gorgeous footage. It's such a beautiful pattern. Look at this. And again, I love the head shape. Like, as far as like, it's got this really cool slope with the eyes on top. The spiracle's really close, but then this like really large snout, kind of sloping very smoothly down. So that's really, really cool. Let's see. Hematera, I'm just catching up with comments. Egg opens the mom, puts out alive. Oh, gotcha. Yeah. I'm definitely need to catch up on my shark literature, but that seems like a long time for the egg case to be out. I don't know. It's a good question. I'm not sure. That's actually a really great question, because I'm not sure what the average time is for egg-laying sharks to develop. But I know when you compare it to live-bearing sharks, a lot of live-bearing sharks have a year-long gestation period. So given that it takes maybe a year, in some cases longer, for some sharks to give birth and for an embryo to develop, it's kind of amazing. I think from that perspective, it's amazing that a bamboo shark can grow so quickly once the egg is laid. But that's a really good question as far as egg-laying sharks. Is that fast or slow in relation to other egg-laying sharks like horn sharks or what am I missing? Horn sharks or cat sharks? There we go, cat sharks. I knew there was another big group of egg-laying sharks. So, but yeah, that's a really great question. I'm not really sure compared to those two groups how long or short that is. So. Love his color palette. It kind of makes me think of like a night sky a little bit. And it's cool to see that some bamboo sharks have more of like a darker tone. This one is a little bit more beige with those beautiful spots. You can definitely see why it has the name White-Spotted Bambooshark. It's a great name, great English name for this particular species. Beautiful shots as always by Andy Merck, great photographer. I really like this one of a white-spotted bamboo shark, partially perching, like kind of lifting off the seabed a little bit with its pectoral fins. Very cool. And fully perching in this photo, so the shark is kind of like pushing off of this coral as he's looking up. It's really great. Oh, that's adorable. These are amazing photos. I love seeing them adjacent to a coral too. This is like a classic like wildlife shot, like a wildlife photograph. Classic like coral reef animal. Like it's like from the books you grew up with. This is just great. This is fantastic. Oh man, these are gorgeous. Great angles with the coral. These are some of his best photos, I think. These are truly exceptional photos of this species. So super cool. All right, Fishbase. Good friend Fishbase. Let's see what Fishbase is saying about this species. So the Latin name is Chiloscyllium. Chilus refers to lip, referring to the membranous and broad lower lip. Skyllion means dogfish or small shark. It also makes me think of Scylla, which is the Greek monster that Odysseus fought. It was also, I don't know if anyone's familiar with, I think it was the Odyssey. Yeah, it had to be Odyssey. I don't know if anyone's familiar with the Odyssey, but Scylla was like the coolest monster where it had like all these different heads and each one was like roaring. It was just super cool. I had a Greek mythology class when I was younger, and like I would there was like an art day, and I would draw like Scylla. It was just coolest thing, really freaky. Oh my gosh. Plagiosum, plagiosis, Latin suffix denoting fullness or abundance. So plagius also means stripes, referring to the dark transverse bands in the body. So this probably, it sounds like it's translating to the small shark with a big like broad lower lips and a lot of stripes on its body, I guess. So kind of an awkward scientific name, fantastic English name, like really great. Usually the opposite is true, but this is actually a really great English name for this particular species. So let's see. A common but little known inshore bottom shark found on rocks and coral reefs. Feeds on bony fishes and crustaceans. Egg-laying or oviparous, utilized for human consumption, also used in Chinese medicine. Boo. Caught by multiple hook and line and trawl. Caught rarely by demersal gillnet fisheries operating inshore. Let's see. Not much else, as usual, for FishBase, but it's always worth checking because sometimes FishBase has a lot of cool info. I do want to check out, we'll check out Sharks for Kids in a second, but I do want to check out, Florida Museum has actually a profile on the species, and they usually are pretty good shark profiles. Oh, well, yeah, high school English class is finally paying off, yeah. Oh, no worries, no worries, Mingus, I didn't notice the typos at all, so... And yeah, they are cousins of whale sharks, so they are closer to whale sharks than they are to cat sharks. Good call there. Let's see, white-spotted bamboo shark. I'm just going to skim through this. Because of their size and adaptability, they are popular in public aquariums. Oh, common names. I love the common names that Florida Museum of Natural History collects. So we got white-spotted bamboo shark. I won't say this one out loud because it's really inaccurate, so I'm not going to say this again. The blue-spotted bamboo shark. And that's it. That's actually a little bit of a letdown. Let's see the other names. We got the Bamboa punteada, which I really like that actually from Spanish. Shalarm gob, Thai. What else we got? I will not pronounce French because I'm really bad at French, so I'm not going to try that. But I like this one. Whitgested. Hold on. Whitgested. Okay. Hold on. The Dutch name. I gotta say this. Whitgested Pelde. Whitgested Pelde. Did I got this right? Whitgested Pelde. Bamboehai. Okay. Bamboehai. I'm glad we don't have Dutch viewers yet, because if we did, they would probably be screaming. Whitgestipelde Bamboehai. That's the best I got. Okay, we're gonna move on. So, why do foreign places have the coolest, even unpronounceable names? Yes. Definitely. Thank you. Major applause for attempt. Thank you. Let's see. We've talked about the fishing on this species before. It adapts well and reproduces in captivity. It's on display in many public aquariums in Europe and the U.S. A completely harmless shark. Let's see. Ooh, like this note, the long, slender body and shape of the species lends itself well to gliding along coral reefs. Currently, there's little known about the life history of the white-spotted bamboo shark. Let's see. Oh, here we go. There are spiracles located below the eyes. no notes on why they're there. There are sensory barbels located near each nostril. Yeah, no, it doesn't describe why they're so close to the eyes. I'm very curious about that because that's so strange. I mean, of all the space on the head, it's kind of amazing to see that the eyes and the spiracles are just that close together. So, great profile, by the way. Again, love how the head looks on the shark. It's really pretty. Although there are other bamboo sharks that are similar in appearance to the white-spotted bamboo shark, this species can be distinguished from others by its unique color pattern. In captivity, there have been 3 albino white-spotted bamboo sharks hatched at SeaWorld in Orlando, Florida. Interesting. Let's see if we can find that, actually. SeaWorld albino white-spotted. Because I'm sure that's something they would like to advertise. I don't know if that's correct. That actually, this image might be correct. Because that... Well, actually, I don't know. That might be... I was about to say that does look like a living individual, but that actually might not be. This is it. Okay. This is it. Okay. No. Maybe Florida Museum and Natural History got confused. These are brown banded bamboo sharks at SeaWorld. But these are albino individuals. So this might be what they're talking about right here. Potentially. So, which is really cool. It is albinism in bamboo sharks, so they might have been confused which species it was. Trying to see if there's new notes on this. The teeth of bamboo sharks are not strongly differentiated in the upper and lower jaws. The teeth are used to clutch soft body prey as well as to crush hard body prey items. Okay. Cool. Oh yeah, no. I just saw this comment. Just yes. So I feel you on that. I got heart palpitation when I heard SeaWorld, but I must hold all judgment. Yeah. So I feel very similarly. And obviously I don't know if anyone has seen Blackfish, which is the very famous documentary on, I think it's Tilikum, but the orca whale. I think it is Tilikum, I could be wrong, but it's the orca whale that was in SeaWorld that killed the trainer. And it's a documentary about SeaWorld's orca program and how really problematic it is because orcas are not only enormous animals that are being confined in a very small space, but they're also just socially extraordinarily intelligent and highly social creatures that just are not happy where they are. So I definitely agree with that. And it's tricky because SeaWorld does do conservation and it does do education, but it is also it's really not good as far as the whales go. That's really, really bad. If I'm not mistaken, I thought SeaWorld, there's a new thing where it's you can't, or not a new thing, but and I won't get derailed on this because I do want to get to the genetics on the sharks, but I thought there was a thing where there's legislation where you cannot import killer whales into SeaWorld or into any marine park. I'm not that versed on them, so I could be completely wrong about that, but let's see. Okay. So just a quick Google search. The current killer whales are the last generation killer whales at SeaWorld. Okay, which is appropriate. So they're not importing anymore, and yeah. So, but it's really problematic. That was a really good documentary. It's really hard to watch, but it's a very, very good documentary. So I definitely, if you're interested in like just conservation in general, marine conservation in general, um, it's like Blackfish is a really, really good documentary. So. Shark teeth specialized for hard prey always fascinate me. Like stretches the definition of teeth I have in my mind. Yeah, it's really cool. I always think of the bullhead sharks, where they have like the crushing plates in the back to crush shellfish and like mollusks. It's really, really cool. So let's see. Just kind of going through the sizes. This is a small shark. Food habits. Not well documented. It's believed that the nocturnal white-spotted bamboo shark feeds primarily on small marine fishes and invertebrates. Okay, this is interesting. The mating season for this species off the Taiwanese coast takes place in December and January, while ovulation occurs from March through May, suggesting that females may be able to store sperm. This is interesting because on sharksandrays.com, the Andy Merck photography website, the diving notes, they're saying that the sharks are mating in Japan in May and June. So this is actually pretty interesting. 1 or 2 round egg cases are released every 6 or 7 days, on average for approximately 2 months. The young emerge approximately 100 to 110 days after the egg case are released from the female. And that's actually really interesting because it's the same time period as far as how long the pups develop in the egg case, but a different timeline as far as when the sharks are mating. And I'm trying to recall if Taiwan is tropical, because well, it has to be. It is tropical. Yeah, no, Taiwan is tropical. Northern Japan is temperate. Southern Japan, I think, enters the tropics. So I was trying to think, like, is the difference in the seasons to do with the temperature regime between tropical and temperate waters? But that probably isn't it. They probably occupy a similar temperature regime. So I don't know. I kind of like this idea. Females may be able to store sperm. That is possible potentially. So as far as like, because that's a very different mating timeline from the Japanese sharks. And then in Taiwan it's December and January, but in Japan it's May and June for mating. So it's pretty interesting. And it could be that the sharks in both places are mating at both times. But I don't know. I'm just putting a pin in that. Let's see. All right. Sharks for Kids, love this conservation website. Just want to check any notes if there's anything new on the white-spotted bamboo shark before we take a look at some heavy science with genetics, which I'm excited about. I'm a little nervous about because genetics gets real tricky real quick, but I think it's worth exploring because we haven't really done that on the stream before. So let's see. A lot of the same notes. This is important though. White-spotted bamboo sharks are targeted by the commercial industry for human consumption and the aquarium trade. So when I was pulling up clips for tonight, and one of them, I think that shark development, like the embryo development clip, it might be from a private aquarium. I hope it's not. But when I was pulling up clips for tonight, I did see a lot of private aquarium videos, and I just, it bothers me as far as like, it's part of it is like, are the sharks happy in their tank environment? Because sharks are, compared to a lot of other animals in aquariums, they're very large and they're very complex as far as their needs. It's less that, which still kind of bothers me, and more how were the sharks acquired? Were they bred captively, or were there invasive, destructive fishing techniques that killed a lot of non-target fish species to get the pretty target fish species in coral reefs, which then like have a huge death rate when they're airlifted from like a tropical place to like Europe or the United States for aquariums. Like I'm really, if it's a public aquarium, I'm more okay with it because there's an education element and there's a conservation element. It's a private aquarium. I'm very like wary of that, and I don't want to give private aquariums views personally, because it's just like, I don't know how good they are for the shark, to be honest, and for the shark's conservation. So I think this is a very important note. Aquarium trade, you know, that is a threat. You know, it's a different kind of fishing, but it is still fishing. So loss of habitat is also a concern for this species. So the happiest sharks are probably ones that are in the wild. You know, as far as just, you know, some fish might. I mean, I would say, I mean, the only fish I know for sure is fine in an aquarium is like a betta fish, because they live in pools in their natural lives. But I don't know. I feel like the happiest shark is probably is a wild shark. So we'll check out sharkreferences.com, because I do want to see the jaws. I do want to see this unique jaw set. Here we go. So, pretty interesting dentition. I can't zoom in on this website, but I don't know if you can see that, where you do have multiple rows of like pointed teeth, but they do seem like they kind of flatten out into like a crushing plate almost. There we go. That's a better view of that. So these teeth do have the points. So if something is snagged by them, you know, it can be stuck and drawn in. But look how flat they are. So you can kind of really see how modified they are, which is a great adaptation for crushing like crab shells or snail shells. So. And this is a very zoomed in image, so these are pretty small teeth. But what's kind of cool is like, look how strong the jaw is, actually. Like, look how much support these teeth have. As far as like, that's proportional to the size of the teeth. That's a really strong jaw. Wow, yeah, that's a lot of power behind that. You know, and it's a really cool evolutionary feature, because you have this architecture where you have like, you know, a lot of power, you know, concentrating to a smaller point. So you have all this musculature that's going to lift like this jaw, where, you know, you have like so much support, but then the actual like lower jaw itself is rounded out into a narrower point. So you're concentrating that force into a pretty effective bite. That's actually really cool to see. I imagine like what I just did was an inference in the shark's biology just based on its skeletal structure, and I imagine, I mean, it's kind of like, I mean, that's essentially what paleontology is, which is really cool. Like, where if you have, you know, a fossil, even if the animal is no longer, you know, existent, and you have no idea, you can't see visually firsthand what its biology was like, you know, the physical form can show you a lot as far as what it likes to eat and how it moves, and it's kind of cool to see that. Or it's actually extremely cool to see that. So, all right. So, wow, actually, there's so much material. It's already 10:13. So I think what we'll do is we'll take a dive into genetics, deep science on the white-spotted bamboo shark. And this is going to be interesting. I don't know. Oh, thank you, Howard. Yes, precisely. Yes. Amazing that cartilage is flexible. Yes. Oh, yeah, definitely. I just saw your comment. The only thing sadder is captive birds. Yes, definitely agree with that. That's just yeah. Yeah, sorry, I'm just laughed at Midge's comment. It's already 10:13. Yeah. So, yeah, I said at the top of the stream, tomorrow is election day in the United States. So it's been. I was talking about spooky season, and then talking about how, election time. It's always like stressful, and then I think it gets exciting the day of, kind of, So. But for the Americans in the stream, hope you have a good election day tomorrow and have fun. Vote. It's important. And yep, that's all I got to say on that. Yeah, I just mentioned that it's just like I think everybody's stressed out this year. So spooky season, election 2024. Gotta love it. This is a cool pamphlet on sharks in Southeast Asian region. So CFDEC. Um, so we do have Chiloscyllium here. There he is. Chiloscyllium plagiosum, the white-spotted bamboo shark. And he's one of many species on here. There's not a lot of information on this, so we'll take a deep dive into the scientific papers. And I think since it's already 10:15, we'll kind of hop around to the genetics first. We'll see how much we can do with the genetics. And I'm just going to say right now, I probably won't be able to... I mean, we'll see. We'll see what happens. So, okay, so age and growth estimates. That's not really genetics. Here we go. Okay, here we go. Oh boy, here we go. Might need some help. So, spooky season doesn't end until election day ends. Yes, exactly. Howard, fossils speak to the ancient past. My favorite are trace fossils like shark tooth fragment embedded in whale bone. That I'm gonna star that. That is really cool. Like that is one of the coolest fossils because you see millions of years later the predator-prey dynamic. And it shows so much information as far as like confirmation. This animal preyed upon this like this animal preyed upon this animal. This is their dynamic. You can reveal so much. Like as far as okay, if we see these fossils together, they probably occupied a similar range. What else do we know about this this area? What do we suspect it was like? And are there other parts around the world? Yeah. I love this mix of subjects of philosophy and paleontology now. Yeah, but seriously, it's paleontology is a beautiful study, and it's like the ultimate detective work. It's really cool to see you're given these clues of the past, and each one is precious as far as it's an insight into a world that is no more, like a world that is beyond where we are now, and it's super cool. So mad respect. I love that comment, Howard. It's super cool. So fast forward, kind of like the opposite end of the spectrum, like the living genes, like the living like genetics today. I feel like shark genetics really took off in the 70s. Onward, and it's an exciting field to study, but very complicated. So we'll see how far we get. So, study of microRNAs related to the liver regeneration of the white-spotted bamboo shark, Chiloscyllium plagiosum. Wow. Okay, this is really cool. To understand the mechanisms of liver regeneration better to promote research examining liver diseases and marine biology. Normal and regenerative liver tissues of the white-spotted bamboo shark, Chiloscyllium plagiosum, were harvested 0 hours and 24 hours after partial hepatectomy (PH) and used to isolate small RNA and mini RNA sequencing. Okay, well now I got to look this up. Hepatectomy. What does that mean? Hepatectomy. Oh, it's a surgical procedure to remove part or all of the liver. Gotcha. Okay. Gotcha. In total, 91 known miRNAs and 166 putative candidate PC miRNAs were identified for the first time in the white-spotted bamboo shark. Through target prediction and Go analysis, 46 of 91 known miRNAs were screened. I think I'll skim. I usually don't skim through the abstracts. I think I'll skim through this and just kind of get to the why and the what as far as why is this important. So here we go. This study provided information regarding the function of genes related to liver regeneration, deepened the understanding of mechanisms of liver regeneration, and resulted in the addition of a significant number of novel miRNA sequences to GenBank. Interesting. Okay. One of my favorite podcasts was talking about. It's kind of a fun question for the chat. Gene modification as potentially the next. They were given the question, what is going to be the next big era in human development? And you think about the agricultural revolution. So when humans went from being foragers to being like a farming society that actually builds civilization. As far as like structured societies. The Industrial Revolution, which made efficiency or like brought a lot of efficiency to production and a lot of pollution, lots of pollution. But there's that. The digital revolution or the like the internet. I mean the internet. Like it's kind of amazing that the internet as we know it. I think it came out in the internet as we know it started in the 90s. It was already existent before then, but the commerce impacting, social impacting internet like is very recent and has completely changed business around the world and socialization around the world. So what's like the next big thing? And one of the podcast hosts was talking about gene editing, where technology is getting to a point where potentially one could edit their genes, and this could actually be very useful for therapy, as far as like Alzheimer's or just like very serious diseases or serious conditions that with gene editing you can actually alleviate some of the effects and the negative consequences, which is really wild to think about. But also if gene editing becomes such a thing as the podcasters were saying. You get into weird questions of like, well, can you pay for gene editing? Can you have someone? And this is like far off as far as I know. And I don't know. I'm not holding my breath of seeing this, but so much has happened, I guess, in my lifetime anyway. So, but it's kind of fascinating to think about. And when you think of studies like this, where here's a liver regeneration study, you can apply it to people with like. Who need kidney treatment, or is there potential in that in the future, as far as kind of understanding the genetics behind. I'm sorry. Kidneys and livers are different. I'm so sorry. Kidneys and livers are completely different. But it's a similar concept where it's like if someone had liver disease, can you apply some of the technologies here, to like human liver regeneration? Is that possible? So it's very interesting to think about. It's a little freaky. And a fun question to think about, and please feel free to answer in the chat if you want to, is if you had the means to do genetic editing for yourself, would you do it? And for me, I would not. I would feel, unless I was like in serious health trouble and it was a life-saving thing, maybe, but just regular like going about my business, like I don't think I would want that. But it was an interesting topic that the podcasters brought up. So really freaky. It almost sounds like surreal, but it's something that they think is going to be like the next major age, which is like, and you think it would be like AI or something. And I mean, we're already starting to enter the age of AI or have entered the age of AI, but it really, the podcast is called, or wait, I can't remember. It's CGP Grey, which is one of my favorite YouTubers. His original podcast with his co-host Brady was Hello Internet, but the second one that he does is Cortex, and I forget who he does that with. Both are very good, but I think he mentioned this technology on both episodes, and it's kind of fascinating to think about. So, yeah. Yes. Oh, cool. Ninjas. Before the 90s, it was ARPANET. It was. I don't know. I did not. What's up, Roy? Welcome back. Welcome back. Yeah, I did not. I did not live in the days of pre-internet. Because I'm a 90s kid. But that's great. Great answer though. As far as, because I think you're right. It is the ARPANET. And yes, I agree about genetics. I just saw your comment about genetics. It's definitely I'm trying to, like, for me, when I was in undergrad, I really loved ecology, behavior, ecosystems, like the larger levels, where you go from like organism up. That's what I really loved. But then when you go smaller, like, and I guess not smaller, but more granular, like health, biology, genetics, molecular biology. Like those were the subjects that were like, oh gosh, these are so hard, and I really don't enjoy learning these, but they are so fascinating and so critical. So yeah, yeah. Whoa, whoa! I'm gonna start this. This is so cool, Minjus. Oh my gosh. I'm not sure if I'm gonna read this out loud if you don't mind. I'm not sure if I overshared about this before, but I'm hoping to go into a career in genetic modification / cloning, specifically for endangered and extinct animals. I have so many thoughts on it. That is really interesting. Howard, I would in my case, and I think it yeah, I think there's scenarios in which it makes sense. You know, I definitely think there are scenarios in which it's something like that is worthwhile. So, and it's fascinating that this is going to be potentially the next age. So, Roy Minjus is going to make Jurassic Park real. Stop him. Oh my gosh. Minjus, have you heard of Chickensaurus, which is the genetic modification program? They did in the late 10s where scientists were manipulating the genes of a chicken embryo to unlock the ancestral dinosaur genes. And they got to a point where they had developed a tail, a featherless tail. And I mean a tail in general, because chickens I guess have a stubby little tail, I guess, but like a long featherless tail, they did get that far, and I think they might have been able to unlock teeth, like where it's not like the chicken's beak, they were actually able to get like teeth, because like all birds are descendants of a lineage of dinosaurs, and therefore within their genes there are the traits that are unlockable, as far as like some traits are turned on, some are turned off, and geneticists are trying to turn on the dinosaur ones. It's like a weird reverse engineering thing, as far as like that goes. Howard, I have concerns about reviving ancient species. Which this is really cool, guys, because this is literally Jurassic Park, actually. You know, because it's literally Jurassic Park. To actually quote Jurassic Park, it's 65 what is it? 65 years of a separation of 65 million years of evolution. How can we possibly know what to expect? Studies like that, along with the de-extinction of the Phrynian ibex, are what made me so interested in it. Oh, that's so cool. So, like, actually, I have a question then, because it's like, I agree with Howard about like dinosaurs, like real, like, these are, I mean, millions of years old. But I'm actually very curious about this with recently extinct species like the thylacine, or is the Phrynian ibex, is that a recent extinction? Like, is that something that happened in the Holocene? Because if it's, I think it would be an interesting thing to explore potentially. I love this. Honestly, dude, I'd love to see an attempt to revive a dinosaur. I think it'd be interesting to explore a little bit about like recently extinct species. But it is also going to be fascinating because, yes, the thylacine. Okay, awesome. Dodos, yeah, dodos are super recent, actually. Like we don't think dodos are recent, but dodos are, on a geologic timescale, incredibly recent. Like 400 years ago. That's nothing on the scale of geologic time. So, and for recently extinct animals, I would be a little bit more intrigued, because they are part of the existing, or should be part of the existing ecosystem as we know it, where they all had a part to play and all interacted with the existing plants and animals of today. I would be curious about what it would be like to revive those animals, I I agree with Howard about further back. Like the further back you go, how disruptive that I would be nervous about that. As far as like if you go to a different era, where you have like like predator birds, like the giant birds that are murder birds. Like I don't think that would be good. But more importantly, beside like from the Jurassic Park scenario, the human harm and everything, there's layers to this as far as like what diseases would these animals bring, like what side effect would they bring as far as if you brought a super ancient animal back, would it become a bizarre like test tube, if you will, of new bacteria, new viruses, viruses and bacteria that, because it's from a completely different time zone, has a severe impact on the current era, which is kind of wild to think about. Because is there something in that genetic structure that's like this incredible breeding ground for new diseases? Because it's not only like the macroorganism, it's like the microorganisms that come with it, which is kind of wild to think about. And like for recent animals, I think it's fine. Like the thylacine probably be really cool because it should be here. But for super ancient animals, I would be really nervous about it because it's like, what would be wrong with that picture? So I'm very curious. And Minjus, as you go through your career, I fingers crossed we keep doing our stream for a very long time. But as you go through your career, I'd love to see just how your research goes, because that's super cool. That is actually one of the coolest things I've ever heard. So cheers to that. That's a really, really cool field of study. Very, very interesting. So just catching up on the comments. Oh yeah. Oh my gosh. Trying to scream, but yes, exactly. They went extinct so quickly on geologic timescale. No animals have been able to fill their niche yet. Howard, I think they're working on dodo as well as mammoth. Oh, mammoth! I forgot about that. Yeah, the mammoth effort, as well as other Pleistocene herbivores. But we don't need is the short-faced bear, the saber-toothed tiger, or yeah, or dire wolves. Yes. Oh no, I agree with that, Howard. I do agree with that. I don't know much about dire wolves, but saber-toothed tigers, like that. If I'm not mistaken, the perfect human predator is a cat. Is like and I believe that was like how you have like the arch nemesis or nemesis of nature, like you have like the fox and the hare, or like the I mean that's a good example, but like the tiger shark and the sea turtle, like these are just nemesises. It's humans and saber-toothed tigers. I feel like that is our ancient awful predator. I mean, we've had a lot of predators in human evolution, but I feel like the saber-toothed tigers were the big ones, because on the plains of Africa, or I guess ancient Africa, like they could like stalk us, they could climb trees, they could like coordinate attacks, like they were huge powerful animals that it was just like that's the scariest thing, real deal. And actually it's kind of cool, well not cool, but like there's echoes of that today where like I was telling my girlfriend I could not imagine hiking in tiger country, like I can't imagine doing that, because it's a smart, stealthy, giant, powerful animal that is actively stalking you. In North America, there's cases of like cougars, stalking humans, and just like I had a friend once who was really into backpacking and camping in like cougar country and grizzly country, and I asked her like, what would you rather face? And she said like, yeah, if I saw a mountain lion, I would just say my prayers. I would just accept death at that point. It's like, really? And she said, yeah, like big cats are no joke. I don't think anyone thought they were a joke, but like they are the natural predators, and it's kind of interesting to see. Like they strike fear more than, I mean, bears are terrible too, as far as please don't bring back we do not. No, yeah, please don't. You know what's really funny about that? Like it's not only that the megalodon would destroy the ocean as far as just knock everything out of balance. It would just, oh my gosh, it would eat all the whales. It would eat all the other sharks. It would just be an awful, awful thing to bring back. But I also do not want to give the conspiracy theorist satisfaction. I don't want them to be right about Megalodon, because they are not right about Megalodon. That thing is dead. It has always been dead. And if we had the shot of resurrecting it, I'm like, no. I'm sick of dealing with these people. No, keep it dead. So, like, from a completely selfish standpoint, no, I don't want it back. I do not want that back. It is gone. It has to be gone. It dead. It died. It dead. So, like, it's just, oh my gosh. Sorry, I would say Megalodon has been, in my whole Dr. Jaws career, as far as, like, the book signings and YouTube and everything, like, that has been the number one thorn on my side, is people asking me, where's the Meg? And I'm like, it's not there. It's just not there. So, like, it's not here anymore. It's a beautiful ancient shark that used to roam the seas, and it's just not there anymore. So, but in a Jurassic Park scenario, if we did bring it back, my selfishness aside, it would cause complete chaos. It would be just you would have to immediately kill it, because it's like, it just would disrupt everything. It would be and it's not like, I sound sensational right now, but I'm actually not trying to be sensational about that. It literally would be like a whale predator, of unbelievable size in an era of, like, that would not work. That would be really bad, because I feel like a lot of our animals have gotten proportionally smaller, like both on land and sea, compared to the past. Like, we don't really have, I mean, we do have gigantism in terms of, like, blue whale. Blue whale is, like, the largest animal to ever live, so we do have that, but, like, proportionally, I feel like we have less species that are gigantic. And so that would just be a wild scenario to think about. So, but yeah, Spot 3. Movie 6 Feet Under. Oh my gosh. Yeah, thank you guys. Get those conspiracy theorists. Oh my gosh, that woke me up. That was. I mean, I'm already awake, but that gave me even more energy. Like, that was a shot of espresso. Oh my gosh, ranting about Megs gives me life. So. By the way, it's 10:30, so this is probably a good time. If you have a shark for next week, please let me know in the comments. Love to cover a new species. I don't have any suggestions currently. I can quickly pull one up from Sharks of the World, but I'm open to anything. It's anyone's game as far as next week's shark. So I love our genetic conversation already, and, like, we've only just looked at one paper, but I actually really love the door that's unlocked. So, and I was just scrolling through the genetic code right here, or genetic codes right here, but this reminds me of that scene from Jurassic Park where it's like, in the first movie, you have the Velociraptor chasing everybody in the control room, and then the reflection of the computer with, like, the genetic codes are right on its skin. And it's just, Steven Spielberg was just a genius in terms of how he filmed it. It's just such a great shot. But let's see. I just want to see if there's anything kind of... This is, like, real deep genetics, so I think as far as the stream goes, we could probably skip some of these diagrams and kind of move on to the next, because I want to cover as many studies as I can, so we'll kind of move on to the next. So here we go. Okay. This is more, it's not quite genetics, I guess, but just want to touch base on this. Isolation characterization of Bacillus species GFP2. So this is like a bacteria, a novel Bacillus strain with antimicrobial activities from Whitespotted Bambooshark intestine. The abuse of antibiotics and following rapidly increasing antibiotic-resistant pathogens is a serious threat to our society. Natural products from microorganisms are regarded as the important substitution antimicrobial agents of antibiotics. Interesting. We isolated, and already in this study, in the past study we just looked at, it's kind of cool to see these are studies that are directly referring to how does this apply to humans, how can we make use of this. It's pretty interesting. We isolate a new strain, Bacillus sp, or Bacillus species GFP2 from the white-spotted bambooshark intestine, which showed great inhibitory effects on the growth of both gram-positive and gram-negative bacteria. Additionally, the growth of salmon was effectively promoted when fed with inactivated strain GFP2 as the inhibition agent for pathogenic bacteria. This kind of makes me think of kombucha tea, or kombucha, where it's like you're actively giving yourself cultures in your human body of bacteria that help promote good diet health. I tried that this summer and hated it, but I think that was just my body not enjoying the kombucha. I don't think it's one size fits all. I think for some people it's a good thing, but yeah. But this is kind of what it's reminding me of. Is like, because like I said about not wanting to bring back a super ancient animal and the bacteria that it, or the breeding ground that it could be for viruses, or the other things that it can bring. Like each organism has a unique like ecosystem of bacteria. Like all of us have bacteria in our bodies. We all have a ecosystem bacteria within us, and it is actually quite delicate as far as like you need good bacteria inside you to help your entire system function. And it's kind of cool to see the study is like talking about that a little bit. So, gene encoding glucanase was successfully cloned from the genome. This protein was detected in culture. The study can enhance a better understanding of the mechanism of antimicrobial activities in genus Bacillus and provide a useful material for the biotechnology study and antimicrobial agent development. Interesting. So, this is diet, so we don't really need to look at that right now. Oh, here we go. Oh, this one's interesting. The white-spotted bambooshark genome reveals chromosome rearrangements and fast-evolving immune genes of cartilaginous fish. Yeah. Chondrichthyan cartilaginous fish occupies a key phylogenetic position and is important for investigating evolutionary processes of vertebrates. However, limited whole genomes impede our in-depth knowledge of important issues such as chromosome evolution and immunity. Here we report the chromosome-level genome of white-spotted bambooshark. Combining with other shark genomes, we reconstructed 16 ancestral chromosomes in bamboo shark and illustrate a dynamic chromosome rearrangement process. We found that genes on 13 fast-evolving chromosomes can be enriched in immune-related pathways, and 2 chromosomes contain important genes that could be used to develop single-chain antibodies, which were shown to have high affinity to human disease markers by using enzyme-linked immunosorbent assay. We also found 3 bone formation-related genes were lost due to chromosome rearrangements. Our study highlights the importance of chromosome rearrangements, providing resources for understanding of cartilaginous fish diversification and potential application of single-chain antibodies. Okay, so that's really cool. I like this line right here, especially providing resources for understanding of cartilaginous fish diversification. So it's kind of like the rapidity of the genes and their evolution is linked to how chondrichthyans could radiate so quickly and radiates in such disparate forms. Like with the 500 shark species. I think there's 1,000 chondrichthyans total because there's about 500 shark species now, or more than 500 shark species, and I think rays is a similar count if I'm not mistaken, but it's really interesting. Fast evolving chromosomes. It's really cool stuff. Just catching all the comments. Ooh. Oceanic white tip. Oceanic white tip. That is a really good choice. I don't think we did an excellent choice. I don't think we did it. let's see. I'm just gonna check really quick. I'm checking my current form playlist. I would be so down for that if we haven't done that yet, because that is a critically endangered shark. It is a gorgeous shark. And extremely dangerous shark too. Like that one is one of the fatal four. Like it's my term for the white shark, the oceanic white tip, the tiger shark, and a bull shark. Those are the four species that are actually super dangerous. And yeah, we're gonna do it. Oceanic white tip. Oh, oceanic white tip reminds me of Van Gogh for some reason. That's really cool. Yeah, let's do it. So, oceanic white tip, Carcharinus longimanus. So that is going to be a really cool shark for next week. I'd love to do it next week. But that one is a particularly cool species. Yeah. Thank you. You need to make that term more popular because it's a sick name. Yes, it's super cool. Oh, thank you. Mike is gonna. Thank you. Yeah, Carcharinus longimanus. This shark is arguably. It's so interesting that it occupies both like. Yes, it is the one. Roy, you're absolutely right. It's the shark that has the fins that look like they've been dipped into white paint. I actually made. I'll have to find the photo at some point, but I did make a white chocolate. I don't know if I mentioned this on the stream. I do like baking quite a lot, especially during the holidays, and I like kind of experimenting with it. But I did make a white chocolate oceanic white tip one year. So I actually did like food coloring and just made this like shark. I did like a mold and like just made an oceanic white tip shark. So I will try to find that photo and put it on the channel. But part of doing that one in particular is because like it has the white tips, so you could do like the white base, like the white chocolate base, and then like do like layers of like brown chocolate on top of it. So, it's just spoilers. Yes, Howard, USS Indianapolis. Oh my gosh, yes. So this species, if anyone has seen, I hope, like Jaws is a very interesting movie because it contributed to a lot of shark overfishing and misunderstanding. Like it villainized sharks and really contributed to their demise. It also is a very well-made movie, very good movie from a movie standpoint, and it did bring sharks into pop culture, in the forefront of pop culture. And I don't know, I would be very interested if someone could make an argument that its existence was a foundation for future nature programs to counter it, and therefore kind of solidify sharks as a fascinating thing that needs to be protected. I'm not going to make that argument because Jaws has been just so negative in a lot of ways, but it would be an interesting argument to make. But sorry, that was a little bit of a tangent. The USS Indianapolis, Howard mentioned it. This was a real event. A real ship that is mentioned in Jaws that sank, and the people who were on the Indianapolis were starting to be attacked by sharks, and this was in the middle of the ocean, middle of nowhere. It was likely oceanic white-tip sharks. This species is particularly dangerous because it hones in on prey items in the open ocean. The open ocean is like a desert, so meeting this shark in the open ocean is like meeting a jackal in the desert. It is very, very dangerous for that reason. I've seen oceanic white-tip jaws back at Vim's, and I have mistaken them for great white jaws. The teeth are really huge, very scary. It's an interesting species that it's both very dangerous, but also critically endangered. So it's a shark that is a dangerous species, but really needs our help. So I'm very excited. It's an excellent suggestion for next week. So we are doing that next week, the oceanic white tip. So that's going to be a really good one. So yeah. So Midges and Howard. These are great comments because it's. I have a friend who loves that movie and loves sharks. I'm not sure if that's exactly what you mean. Jaws equals shark kill equals shark conservation. Yes, and then Howard, the backlash from Jaws did solidify the shark protection community. Yes, so yeah. Between the two comments, that's exactly what I mean as far as like, it was a negative. It was definitely a negative impact when it came out, but its negativity kind of was an anchor for a dialogue that has evolved into like Shark Week, evolved into like, you know, just so much discussion on sharks in general. I will say personally, I mean, when I was like a little kid, like I saw Jaws and thought it was super cool. Like, and it's not the reason why I love sharks, but it was like, I don't know, there was something about it that like it did expose me to sharks and made me think, oh, they're just so cool. So I don't know, it's interesting. It'll be an interesting conversation to have, just to hear someone have a back and forth about the merits and vices of Jaws. It'll be interesting. So yeah, but yeah, that's gonna be a really great Shark next week. I want to just scan through a couple more genetic articles because this has been we got a little taste of it, but already it's been pretty fun as far as like seeing. Oh, can we do this? I think I know what this is. Is this genetic phylogeny? No, this is kind of not. This is beyond me for a Monday night stream. Oh dear, yeah. Bamboo shark, chicken, are they the same? Like, yeah, this I would not be able to decipher this. Mandaka, what is a Mandaka? I don't know what that is actually. Let's look that up. So. I really do love seeing, and it makes complete sense, but it's cool seeing as far from a genetic standpoint how similar we are to fellow animals. Like on a genetic level, we share a lot of the same traits, and it makes sense. Like bamboo sharks, chickens, us, we share like a pair of eyes, like a mouth, a nose, a pair of ears, like that. It's like I feel like in our day to day we take that for granted, but like there's a reason why we share these things. It's because we all share the foundational genes that creates those features. It'll morph them into different shapes, but they're fundamentally the same features because we fundamentally have the same code, which is really cool. It's kind of amazing to think about. I'm just gonna look up Medaka because I've never heard of that. Oh, it's a fish. Medaka, also known as a Japanese rice fish. Okay, but yeah, this particular graph, I'm not exactly sure what this means. I'm like, shark, chicken, are they the same? Is a chicken a land shark? Is a shark a sea chicken? I don't know. I'm just being silly at this point. So, let's see. This is more conservation. We'll keep moving. This is not. Well, it's tangentially related to genetics. I am kind of curious about this. Artificial insemination and parthenogenesis. So this is birth without a father. This is like probably shouldn't say virgin birth, but it is like virgin birth. It is like a mother or female shark giving birth to a offspring without paternal influence, so without a father. So artificial insemination and parthenogenesis in the white-spotted bambooshark, Chiloscyllium plagiosum. Okay, I'm kind of curious about this. So, non-lethal methods of semen collection from the Lazaranks to better understand species reproduction has accompanied development of artificial insemination. Let's see. Females are inseminated with fresh 24 to 48 hour cold store raw extended semen, and paternity of the offspring determined with microsatellite markers. We'll just kind of keep breezing through this. 2 females inseminated with fresh or cold store semen laid eggs that hatch from fertilization and parthenogenesis within the same clutch. Parthenogenesis rate for inseminated females was 0.71%. Results demonstrate artificial insemination with cold stored semen can provide a strategy to transport male genetics nationally and internationally, precluding the need to transport sharks. So this is actually applicable to aquaria. So this is like if you're public aquariums who are trying to do breeding programs, you don't have to capture the shark and move it from one continent to another and stress it out. You can actually just collect its sample and just transport the sample. So that way you actually save the effort of capture, and more importantly, you save the shark from getting stressed. So production of parthenotes in the same clutch with sexually fertilized eggs highlights the prevalence of parthenogenesis in white-spotted bamboo sharks and poses important considerations of population management. Very interesting. So, I have 5 minutes left, so I'm going to knock out some of the rest of these. Immaculate conception in sharks. I love that, Howard. Oh my gosh. Midge's virgin birth in the most literal biological sense. Yes, I mean, pretty much. It's like I feel like from a scientific lens, it's not the right term to use, because it's very like evocative and flowery and kind of more like a cultural oriented term as opposed to like a scientific term. So, but but it's very good shorthand as far as like it's basically what it is. So, which is pretty funny. Oh my gosh, Howard, yes, Jaws is part of shark culture. Yes, so. For sure. I mean, for sure. Yeah. And like, cause you know what? Jaws is not just, it's not just the shark is a villain and we're going to hunt it. It's also like, Hooper, the marine scientist, who loves sharks, says he loves sharks and is kind of approaching the situation from like a scientific lens. Hooper is really funny in that movie because I think I mentioned this before. There's some things that he very passionately says and are wrong, and part of it is outdated science and part of it is just wrong. So this is why we must worship sharks. Actually, yeah, it's this is why we must worship sharks. Love that comment, and it's actually kind of cool. I know it's taken light, or it's I know it's kind of more of a joke, but it's kind of cool to tie it into culture. Some cultures have worshipped sharks, like Polynesian cultures, some North American cultures. It's kind of cool. It's kind of like I know it's a joke, but it's like it's kind of fun to tie into like, oh yeah, I mean, sharks are worship have been worshipped. I was trying to think of an adjective for that, but I can't think of one. So have been worshipped. But yeah, Hooper, what did he say? He called the great white a squalus, which is really weird. That's taxonomically wrong. He said he had some goofy theory about the shark, like being. I don't know. I had to. It was about using Martha's Vineyard as like its territorial stake. Or something, and it's like, no, that's not really what they do. I don't know. It's goofy stuff. So, but I guess the point of that little tangent is there is a character in there who is not saying that the shark is a monster. He's studying it and studying the biology, and just it's interesting. A lot of different. Actually, everybody's involved in it because you have the fisherman in Quint, the scientist in Hooper, and then I'm gonna say just like the layperson in Brody. Like as far as like he doesn't fish and he does not study sharks. He just is a guy who wants to protect his community, but kind of more importantly, he's kind of like I guess he's the Axis character. He's kind of like most people as far as like whether or not they know sharks. So it's good storytelling. It's a very interesting movie as far as that goes, but. Anyway, I gotta stop talking about Jaws. Identification of circ RNAs in the liver of white-spotted bamboo shark. I think this is an offshoot of the other liver study. It is about liver regeneration. Let's see. Okay, I think it's an offshoot of the other study, so we'll just kind of keep looking. We did see this one already. The white-spotted bamboo shark genome reveals chromosome rearrangements and fast-evolving genes of cartilaginous fish. Very cool. Oh, did I already click on these? I might have double-clicked on these. Sorry about that. This is more... Oh. Wait a minute. Oh, actually, okay. This would be a good one to close out on. This was so earlier tonight. There was a reference to the bamboo shark, the white-spotted bamboo shark, changing its teeth orientation depending on its prey item, and this might be that study. So let's check this out. It's by Bradley Scott, Elizabeth Brainerd, and Cheryl Wilga. Long axis rotation of jaws in bamboo sharks during suction feeding. So here we go. Long axis rotation (LAR) of the jaws may be an important component of vertebrate feeding mechanisms as it has been hypothesized to occur during prey capture or food processing across diverse vertebrate groups including mammals, ray fin fishes, sharks, and rays. LAR can affect tooth orientation as well as muscle fiber direction and therefore muscle power during feeding. However, to date, only a handful of studies have demonstrated this LAR in vivo, meaning in life. Here we use XROM to document LAR of the upper and lower jaws in white-spotted bamboo sharks during suction feeding. As the lower jaw begins to depress for suction expansion, both the upper jaw and lower jaw evert, such that their tooth surfaces move laterally, and then they invert with jaw closing. Eversion has been shown to tense the dental ligament and erect the teeth in some sharks, but it is not clear how this tooth erection would contribute to suction feeding in bamboo sharks. 2 recent XROM studies have shown LAR of the lower jaws during mastication in mammals and stingrays, and our study extends LAR to suction feeding and confirms its presence in shark species. Examples of LAR of the jaws are becoming increasingly widespread across vertebrates with unfused mandibular symphyses. Unfused lower jaws are the plesiomorphic condition for most vertebrate lineages, and therefore LAR may be a common component of jaw mechanics unless the mandibular symphysis is fused. So this is really cool. This is talking about how the shark is changing its jaw structure during feeding. I like how it is talking about the basic features of a shark jaw. So the upper jaw is the palato quadrate, the lower jaw is Meckel's cartilage, and I've mentioned Meckel's cartilage on the stream before. I hope they have a diagram about how this works. And this is it. Okay. It's going to be kind of tricky. It's talking about the jaw structure is changing during feeding. That's not a really easy... this is really cool. Oh, actually, yeah. Here we go. Here we go. Okay. Cross review. Okay. This is very tricky, but here's what's going on. So, okay. So here's the upper jaw, or palato quadrate. Here's the lower jaw, which is Meckel's cartilage. And then here they are in this photograph too. So this is looking at the shark from the side. This is looking at the shark from the nose right here, downward at an angle down like the vertebral column. So you can see the vertebral columns here in figure A. It's kind of on this side, and then figure B, it's kind of tilted at a weird 45-ish degree angle on this side. So this way you can see how everything is moving. For ease, they have, you can follow these little points right here. Let me zoom in, because this is actually really cool. I actually like, this is a better figure, kind of pointing out what's going on. So circle to circle. So the circle point here is the same thing as here. Star to star. Star here is star here. And then triangle to triangle. Triangle here, triangle there. So here's like a lateral view. So a view of the left side of the shark. Say if this was me, you're looking at the left side of my face. And then here, if this was me, you're looking at my face. You know. So so there we go. So here's like the standing or stasis position, or like stable position. Here is eversion, so you can see how the upper jaw starts kind of like, I guess by comparison, the upper jaw is moving a little bit independently of the chondrocranium, like this beige area, and then the lower jaw is widening. and moving a little bit differently, into a different spot in relation to the chondrocranium. And then inversion, the jaws close and they're closing at a weird angle. Gotcha. Okay. So it's not only that the shark is protruding its jaws and launching back, it's also kind of making a weird angle, and the weird angle is changing how the teeth are oriented. Because remember how we saw here, where is this? You see how these are like points, but they're also flat? So it's like if you had it at a certain angle, the points can come up and kind of like clutch the prey, grab the prey. But if you change the angle on it, you're going to get the flat edge, and that's going to crush prey. So that is actually extremely cool. I think that's the basic concept of this study, which is really remarkable, honestly. I wonder if they have more on this. This would be really great to see in a video, because this stuff, I mean, this is really hard to kind of show in 2D. If you had like a 3D video, that would actually really be great to watch. I wonder if they will have something like that. They probably won't. So, but I think we kind of got the basic concept as far as what? Okay, is this it? Is this it? Is this a video? Is this a thing? Oh, okay. Can I watch this? I don't know. Am I able to see this? This might be the stuff. I know it's past 11, but I'm kind of curious about this. I don't want to open a zip file because I just don't think we have time, really. What's this? There we go. Okay. Okay, so there are video files here. So I think what I'll do, because I know it's 11, and we probably won't have time to go through every one, I will leave this in the chat because I think this is it. Where somewhere around here are videos where you can see the jaw structure moving, and this very unique feeding strategy moving. So I want to make sure I get back to the start of this. Oh, nope, my session has not timed out. I'm doing a live stream. Okay, here we go. Okay, so if anybody's curious, I'll just like leave this here. If anybody wants to watch this, because I'm sure I've been on sites like this before where they will have like a 3D model of the jaws, and you can see them in action, and then it looks like they'll have clips of actual specimens. Probably don't have time to go through all of them right now, but just, if anybody's interested, I will leave the link in the chat. So, but, and just, catching up on comments. So, oh my gosh. Love the shark worship comments. Fantastic. Well, I think with that, we'll probably wrap up for tonight. Not with an ad. No, get me out of here. I don't want an ad. No, they're going to keep showing me ads. I want a clip of the white-spotted bambooshark. I guess we will do this one, which is embryonic development. It's probably a good one to end on. But anyway, thank you guys so much for watching. This was a really interesting stream. This was really our first... we've done a couple... It's rare that we do genetics stuff. We did a couple, I think more so last year, especially with gene complexes or shark complexes where, you have multiple species hiding in plain sight. But we haven't really done one like this where we get to talk about the actual genome of sharks and how they relate to human needs and human interest, and specifically the white-spotted bamboo shark. There's studies about liver regeneration, which is really interesting, and that opened up a really cool conversation. So I really loved having that with you guys, and as always, this was super fun. So thank you guys so much for watching. Tune in next week for the oceanic white-tip, Carcharodontis longimanus. That is a can't-miss species. It is in dire need of conservation support. and is also a fearsome predator in its own right, with a really distinct look. It is a beautiful open ocean shark, so I'm very excited to cover that next week. So thank you guys so much for watching. Have a great rest of your week, and I'll see you next week for the oceanic white tip shark. Cheers, guys, and take care. Bye.